Let's have a little bit of a chat about the discriminant. So as I mentioned before, it's that bit under the square root sign in the quadratic formula, so b squared minus 4ac. And so that can tell us a lot of things. It can tell us whether the roots are going to be rational or irrational. If the discriminant is greater than 0, so if it's positive, then we know that there's going to be two different real roots. As far as the picture goes, that means it'll cut the x-axis twice. If the discriminant equals 0, there will still be two roots. They're just going to be the same. So they are two equal real roots. Now this is the difference, I guess, between a root and a solution to the equation. There would be only one solution to the equation, but there are actually two roots. They happen to be the same. And if we were to draw the picture, it would just touch the x-axis. Discriminant is less than 0. Well, it says there are no real roots. That's true. There are still two roots, but they're both imaginary. Okay? A quadratic always has two roots. In fact, any polynomial has the same number of roots as its power. Some may or may not be real. Okay? So for the purpose of what we're looking at this stage, the quadratic always got two roots. Discriminant greater than 0, then they're different. Discriminant equal to 0, then they would be the same. And if it's less than 0, they would both be imaginary, so there are no actual real roots. If the discriminant turns out to be a perfect square, that's when the roots are going to be rational, because it means we can find the square root if it's a perfect square. Okay, so let's describe them. So we don't actually have to go and find the solutions. Just by using that idea of discriminant, we can describe them. So the discriminant for this one, b squared minus 4ac, is negative 83. Well, that's the quickest of them all, because as soon as it's negative, I know there's no real roots. So there's nothing to describe here. So it's got no real roots. 2x squared plus 6x minus 3. The discriminant is 60, so it's positive. So now I can describe it. What are all the things you can tell me about the roots of this equation? Okay, so hang on, what was that one? Someone said it?
It's
irrational, because we don't know what the square root of 60 is. Okay, we know that. What else? We know there's two of them. We know they're real. We know they're different. So to put that all together, we've got the two different, real, irrational roots. Well, let's say we want to force this equation to have equal roots. What value of k would we use? Well, the condition for equal roots was that the discriminant was equal to 0. So let's see what we need to make k equal to. So b squared minus 4ac, k in this case would have to be 9. So if we make k equals 9, we're going to have equal roots, which of course would make this a perfect square, if you think about it. So if they're equal, two equal roots is like saying one solution to the equation. So yeah, of course k had to be 9 there, because we needed to get x plus 3 all squared. What about if we wanted ones that have unreal or imaginary roots? Well, the condition on that one was the discriminant had to be less than 0. So there'll be a variety of values for k. We've got to solve the inequality. Minus 4 squared minus 4 times 2k is less than 0. We end up with k is greater than 2. So as long as k is greater than 2, then we know there'll be no real solutions to that equation. Real roots. The condition for real roots, what would it be? Right. It's going to be greater than or equal to, because there were two situations where we had real roots. One where they were equal, one where they were different. So combine the two, greater than or equal to, so b squared minus 4ac, k squared less than or equal to a quarter, which means k would be in between minus half and a half. Seems an odd question to ask here. For what value of a is the line y equals ax, so a line that goes through the origin, a tangent to this circle? Well, if you wanted to find where that line hit the circle, how would you find it? There you go. Sub in y equals ax. In other words, solve them simultaneously. Now, if it is a tangent, how many solutions should I expect?
One.
Okay. Well, let's see what happens. Sub in y equals ax, and you can see we've ended up with a quadratic. Now, if this quadratic only has one solution, what does that mean?
B squared minus 4ac is equal to 0.
So the discriminant is equal to 0. I don't actually have to go and solve the equation. So I can say, well, look, I know it's going to be a tangent when the discriminant is 0. Well, there's one solution. B squared minus 4ac. Gosh, that should be dividing by 100. There we go. 3a squared plus 4a is 0. We had two possibilities. A is 0 or A is minus 4 and 3. So 8f.